Hello, this is Tara Zan. I'm here with you with a new episode of Molecule That Changed the World. We're going to focus on DDT today, and we have our guest, my good friend, Dr. Lee. Thank you so much for coming today.
Thank you, Tara. It's great to be here. I'm here today to talk about DDT, which is an organochloride insecticide that kills insects by opening sodium channels in their neurons and causes these neurons to fire spontaneously. It was a cardinal weapon used in World War II to fight both malaria and typhus and keep our troops safe from infectious diseases. According to the USNAS, to only a few chemicals does man owe a greater debt than DDT. In little more than 2 decades, DDT has prevented 500 million human deaths due to malaria that otherwise would have been inevitable. So if you notice here, Tara, the health workers actually sprayed a Malaysian village with DDT in order to kill off the mosquitoes and control malaria. However, a couple unforeseen side effects occurred. The DDT actually ended up killing the village's population of wasps. Now, the wasps were feeding mainly off of moth larvae. And with the wasps gone, the moth larvae were flourishing, and they ended up eating the huts of these villages and deteriorating them. And so the cockroaches that were living in these huts were feeding off the hut debris. And while the DDT that they would ingest did not affect the cockroaches directly, the geckos that would eat the cockroaches would then become weakened by the DDT that they got from eating the cockroaches, which made them a prime target to their predator cats. When these cats would get infected by DDT, it would greatly affect them and it would end up killing the cats. With all the cats gone, the rat population in this community rose greatly, resulting in an increase in typhus and plague spreading. It even got so bad that the World Health Organization had to fly in a reinforcement platoon of cats to control the rat population in the village.
Thank you.
You're welcome.
Thank you so much for joining us for our new episode on DDT, and thank you so much, Dr. Lee, for coming in and give us a lot of information about this molecule.
It was my pleasure. My only hope is that they'll start teaching more about DDT in schools.
Good morning, everyone. Please take your seats. I hope you all had a nice weekend. I know I did. Also, please silence your phones. Tara, if you could please get off Facebook, that would be great. So today we are going to learn about DDT. And first we will go over the DDT formation mechanism, which is a very interesting mechanism, and it employs some reactions that we have already learned, such as electrophilic aromatic substitution. But there is a twist, and the first twist involves the generation of a benzylic carbocation intermediate, and this will function as our key electrophile. Okay, so we have our trichloroacetaldehyde right here, and that is going to react with our sulfuric acid to form a carbocation and hydrogen sulfide ion. Okay, so the first step is our benzene ring is going to attack the carbocation. And then as a result, is going to form a carbocation inside the ring. And
that hydrogen bond gonna stabilize our aromatic ring, right?
Yeah, so now we need to stabilize our ring because we know that resonance stabilization allows the transition state energy to decrease, which lowers our activation energy and also increases our rate of reaction.
Interesting.
Okay, so now this is going to pull off that hydrogen, which is going to get rid of the carbocation. And so now we have stabilized our ring right here. So our next step is for, what do you guys think the next step is going to be? Yes, Alex.
It looks like that hydroxyl group is taking on another hydrogen to make water, which is a good leaving group.
Yes, very good. So we know that water is probably the best leaving group. So exactly, this hydroxide is going to pick up the proton right here. And then when it does that, water can just leave, which regenerates the carbocation. So we're getting close to our final product.
Looks like that carbocation is susceptible for another nucleophilic attack.
Yes, very good, Alex. So same thing is going to happen here. And now we have our hydrogen sulfide ion is going to pick up this hydrogen proton again. And now we have regenerated our aromatic ring.
Stabilizing the molecule once
Yeah.
again.
Nice.
All right, everyone, so we have our final product, dichloryl diphenyl trichloroethane, also known as DDT.